Hello everyone, welcome to Succeed e-learning app. Today we are going to learn a very interesting topic called as an metals and non-metals. The topics we are going to cover in this entire chapters are what is metal, what is non-metal, physical and chemical properties of metal, physical and chemical properties of non-metal, ionic compounds, extraction of metals and refining of metals. Now let's see what is metal and non-metal. Metals are the substances which donates the lone pair of an electron, and non-metals are the substances which accept the lone pair of an electrons. Let me give an example for metal. Gold, silver, all these are metals, and non-metal examples are hydrogen, chlorine, carbons. Those are a very good example for non-metals. Now we'll see the properties of an metals. Metals are solid except mercury, which is a liquid at room temperature. I am talking about only the room temperature. When it comes to the matter of an room temperature, all the metals are solid except mercury. Metals are good conductor of an heat and electricity, and metals are lustrous, metals are sonorous, metals are ductile, metals are malleable. Properties of non-metals. Non-metals are bad conductor of heat and electricity, and non-metals may be solid, liquid or gas. Non-metals are non-sonorous, non-ductile, non-malleable. Let's see what is ductile. Ductile is a very important properties of any metal, because this metal can be beaten into a thin wire and which is mainly used for electrical purpose. Example, copper, iron, etc. Now let's see what is malleable. Malleable is it's also an important properties of any metal, because the metal can be beaten into a thin sheet. Example, aluminium foil, which is used for packing of an hard food, right? So we see that foil which is very thin, that is a metal. Now let's see what is lustrous. Lustrous is a very important property of any metal, because it shows the shining appearance. Because of this property, if you drop a key in a dark room, definitely you cannot find that. Suppose if you switch on the light, immediately you can see that key, right? This is because of the property called as an lustrous. Yes, now let's see another important property called as an sonorous. The most beautiful sound of any student is the last bell of the school, right? Yes, that property of a metal is called as an sonorous. What is sonorous? Sonorous is nothing but when one metal strikes the another metal, it produces an sound. That property of a metal is called as an sonorous. Now it's time to know about the chemical properties of an metal. I mean, what happens when metal is reacted with air, water, steam, all those things. Now let's see what happens when metal is reacted with air. All the metals will not react with the air, but whenever the metal reacts with the air, it forms the respective oxide. Let me give an example. When sodium is reacted with an oxygen, it forms the sodium oxide. But sodium, when it is react with air, it reacts vigorously. That's why the sodium is preserved under the kerosene. Now let's see what happens when metal is reacted with water. All the metals will not react same with the water. Some metals, example sodium, reacts with the cold water, magnesium reacts with the hot water, and aluminium reacts with the steam. But when all the metals react with water in any manner, like in case of with hot water, cold water or steam, the product will remain the same. Example, when sodium is dissolved in water, it forms sodium hydroxide and hydrogen gas. Like that, whatever the metals react with the hot water or the steam, the product remains the same. Now let's see what happens when metal is reacted with an acids. In previous chapter called as an acid, base and salt, we saw that when metal is reacted with an acid, it forms the respective salt along with the liberation of an hydrogen gas, right? In the same manner, when the zinc is reacted with the hydrochloric acid, it forms the zinc chloride along with the liberation of an hydrogen gas. Another example with the another acid, when magnesium is reacted with an nitric acid, it forms the magnesium nitrate along with the liberation of an hydrogen gas. Now let's see what happens when one metal is reacted with the other metal salt solution. If you want to know this very clearly, you're supposed to know what is displacement reaction, right? In displacement reaction, the more reactive element displaces the less reactive element and it forms a metal, right? The same thing happens when the metal is reacted with the salt solution of an other metal. Let me give an example. When zinc is reacted with the copper sulfate solution, zinc being more reactive, that replaces the copper and it forms the zinc sulfate solution along with the formation of an copper. From this experiment, we can arrange the metals in the order of an decreasing activities. From this experiment, we got a series of an arrangement of an element called as an reactivity series. Now let's see what happens when metal is reacted with a non-metal. In the beginning itself, I told you that metals are electropositive in nature. That means they are ready to donate the lone pair of an electron. In case of a non-metal, they are electronegative and they are ready to accept the lone pair of an electron. Because of this property, when the metal loses an electron and when the non-metal accepts the electron, and because of the opposite charges, these two combines and form a new compound called as an ionic compound. When magnesium releases an 2 electron, whereas the chlorine accepts the 2 electrons, they combine to form a new compound called as an magnesium chloride, which is an ionic compound. Now let's see the properties of an ionic compounds. Ionic compounds are solid. Ionic compounds have high melting point and boiling point. Ionic compounds can dissolve in water. Because of this property, ionic compounds can conduct an electricity. After learning so much about the metals and the non-metals, their physical properties and their chemical properties, we are supposed to know from where we are getting these metals, right? The metals are getting from the earth crust in the form of an minerals and the ores. Minerals are the elements of compound which is occurring naturally. Minerals from which the metals are extracted profitably is called as an ore. Example, sulfide ore, carbonate ore, etc. Now let's see the elements which is present in the reactive series. The metals which is present in the bottom of the reactive series, just like a gold, silver, all are present in the free state. The metals which is present in the middle of the reactive series are usually combined in the form of an oxide, sulfide or carbonate, and the metal which is present on the top of the reactive series usually present in the combined state. From this we got to know that the extraction of an metal from the minerals or the ore is an highly difficult work. The metals alone it will be not present, it will be always combined with one or other things. Suppose the metals are present along with the sand, soil or other impurities, then that impurities are called as an gangue. There is a technique called as an metallurgy which is used to extract the metals from the impurities. That process we usually call it as an metallurgy. That is what we are going to study now. Now let's see the steps involved in the metallurgy. First we will see the metals which is present in the low reactive state, how to extract those metals. When the metals of a low reactive series is heated at high temperature in the presence of an oxygen, it forms the pure metal. I mean it increases the concentration of an metal. Example, extracting the mercury from cinnabar. When the cinnabar is heated in the presence of an oxygen, it forms the mercury oxide along with the formation of an sulfur dioxide. The mercury oxide which is formed when it is heated over and over, it forms the mercury, and along with that it releases an oxygen. Now let's see extraction of an metals from the middle of the reactive series. The metals can be extracted very easily in the form of an oxide, in the state of an oxide when compared to the sulfide or carbonate. So any metal which is present in the sulfide or carbonate, that can be converted into oxide state by two methods. One is calcination and another is roasting. What is roasting? The process of heating the concentrated ore below its melting point in the presence of oxygen is called as an roasting. Calcination. The process of heating the concentrated ore below its melting point in the absence of an oxygen is called as an calcination. The metal oxide which we got it from the calcination and roasting, it should be reduced to get a pure metal. This can be done by two methods. One is by using reducing agent and another method by using displacement reaction. In case of an zinc oxide which is got it from the calcination, that is heated in the presence of an coke. Here the coke acts as an reducing agent. When it is reduced with the coke, the zinc oxide will form zinc along with the formation of an carbon monoxide. Another method, displacement reaction. This already we know that the more reactive elements will displace the less reactive elements. By this method we can get the pure metals. Now let's see how to extract the metals which is present in the top of the reactive series. The metals which is present in the top of the reactive series have more affinity to the oxygen than compared to the carbon. So there is a suitable method called as an electrolytic reduction. The metal like sodium which can be extracted by this method, when sodium chloride is dissolved in a solution, as soon as we pass the electric current to that, the Na plus Cl minus will be formed, so that the sodium metals can be extracted easily. After extracting of a metal, we need to do some extra process called as an refining, because the metal which we got it from the extraction process, still it contains the some amount of an impurities. To remove those impurities, we need to conduct an experiment called as an electrolytic refining. The copper which can be easily and very good amount of an copper, we can get it by electrolytic refining. For this we need to set up an experiment by taking an electrolytic refiner. The electrolytic refiner contain anode, cathode and electrolytic solution. The electrolytic solution is nothing but copper sulfate here. So when we pass the electric current to this copper sulfate solution, the copper sulfate will dissociate into copper and sulfate. The copper what we get it from here will be almost more than 95% pure, and there will be some impurities like gold, silver which will be deposited at the bottom of an anode called as an anode mud. Let's see what is corrosion. When the metal is reacted with the surrounding substances like air, moisture, it loses its physical property. Just like when the silver is reacted with the air, it loses its property and turns into black color. Copper turns into green color. The corrosion which takes place in a metal like iron is called as an rusting. Yes. Now let's see how to prevent the corrosion. Corrosion can be prevented by applying paint, oil or grease, and by also method called as an galvanization. By doing so method, we can prevent the rusting or turning of the physical features, etc. Alloy. What is alloy? Alloy is a mixture of an metal with another metal or metal with a non-metal. By doing so, we will get a new substances called as an alloy. By adding carbon to the alloy substances, the alloy substances will become strong as well as hard. Example, stainless steel, which is a mixture of an iron, nickel and chromium. And another very good example, solder, which is a mixture of an tin and lead, which is mainly used for the welding electrical wires. Hello, welcome to lab section. Here my friend is going to perform an experiment for you. This is all about when metal is reacted with an acid. As we know that whenever the metal is reacted with an acid, it forms the salt along with the liberation of an gas called as an hydrogen, right? He is going to perform now. He is taking H2SO4 in one test tube and adding a small amount of an zinc granules. As soon as he added, there is a reaction and the product is going to form now. The product is ZnSO4 along with the liberation of H2 gas. Here ends our experiment 1. Let's go with the experiment number 2, that is preparation of an sodium hydroxide. The sodium hydroxide can be prepared by passing an electric current into the brine solution. As soon as we pass the current into the brine solution, the NaCl which is present in the solution will split into Na plus and Cl minus. The same way, the water which is present in the solution will also split into H plus and OH minus ions. Here, as the electric current is passed, the Na plus will combine with the OH and it forms the sodium hydroxide. Here ends our topic, metals and non-metals. Hope it was an enjoying one. We'll see you in the next video. Till that, keep watching Succeed E-Learning app.